guys, welcome to day 21, and today we are going to be talking about generics, and this is great. We've been talking about this for a while, and now we're actually going to talk about it. We're going to get into it and learn what generics actually are. And so what are generics? Well, they allow you to generalize what you put in your data structures. They do other things too, but we're going to focus on this for now. Remember how we had to say our linked list is going to take strings, ints, booleans, and we couldn't just let our linked list be, we could decide what was going to be in it on the spot. We had to literally say this data type has to be a string. You may not remember, but that's okay. And generics are going to fix that. Now our queues, stacks, lists, they can hold any type of data, but that data type should obviously be consistent throughout the data structure, which means that if I have a Boolean queue, it's going to hold Booleans, and I can have an int queue, it's going to hold ints, but I couldn't have a queue that holds Booleans and ints because it gets all confusing, and it's better to have, your thing straight. But if I wanted something that had a Boolean and an int, you could just create another object, say boolint, and you could have your queue hold boolints, and it would have, two parts to, what are they called? Attributes, properties, fields, and yeah, you get what I'm saying. You can get around anything. Java is a strongly typed language, meaning you have to declare the type of a variable on declaration and you can't change it afterwards. And so if I have an int a, I won't be able to change a into a string. It always, whatever value I give it, it has to be an integer. How does this fit in with generics? Officially, generics allow a type or a method to operate on objects of various types while providing compile time type safety, which is a lot of words, but basically it means your stacks and queues can hold different persons, trees, and strings, and the compiler won't complain because those data structures, those containers, should be able to hold anything no matter what you're giving it. If you're giving it ints, people, trees, pedestrians, it should be able to hold that and not worry about, and not even think about what type is in it, have that be an abstraction. Now we are going to open NetBeans, and we're basically, NetBeans, here we are. And with this NetBeans, we're going to go back to some of our old projects and make them generic. And so we're going to make some generic methods and solve some of our older problems. And so this is booting up as slowly as possible here. And we're going to do file, open project, and wherever you save this, this is where all of my little practice. Oh my God, we've made so many projects. Oh my God. Okay, we're going to array practice, in case you were curious. And so the last time we did array practice, we basically, if you remember, this was from early days. This was from the, before you really knew what you were doing. And here we basically created this method called print array, and what it did was it printed out the array. But because we had to say, oh, it's an integer, oh, it's a string, and we had to literally we had to pull something out. We couldn't just say this is an int array. We couldn't just say it doesn't matter what's in the array, just print it. And so here we have two methods, and we're actually going to change this first method so that it works so we don't have to do both methods. We can just have one and it be called and it'd be great. So how are we going to do this? That is a good question. So after static, we are going to add this thing e. And e is just going to be this is going to be any type of element that can be here. So we're going to change our int here also to e. And this is going to error. We'll comment that out for now. So what this is saying so far is, and I don't know, why you got to comment? Okay. What this is saying so far is that we have this e data type, and e can be anything. And what can be anything? Well, anything can be in this array, but of course, because the way that string array works and int array, it basically means that anything inside this array has to be of e data type. So e could be int, string, boolean, but it doesn't have to be any of those. It can be object, but it does have to be e. And so when we do this pulling out of the item, we can do e item, and it's going to be happy because everything is of type E. So when this compiles and when it gets E is going to be either Boolean, int, whatever it is. And so if it's an integer array that's being called with this method, the integer array is an argument, then E will be int, E here will be int, and then this will be int. But again, if it's a string array, then E would be string, 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 character, the same thing. And we are going to simplify this method because it has a lot of words, lots of lines, almost 20, and that's not good. We can simplify this. And so take a minute and simplify it if you want to. I'm going to do it right here, and instead of doing this annoying iterativeness, we can just do for e elements And we can just say this is a for each loop if you remember this. And so it's saying for each element in the array that is of type E, which could be string, we don't know what it is until we actually call the method. It depends on the value of the argument. For each element in the array, we are going to do a system.out.println, and we are just going to print out this element here, and we're going to just print out elements. And this is fantastic. And because everything can be printed, no matter what it is, like, this is cool. We can have this guy here. And so we are actually going to delete all this annoying stuff. And we can delete that. So we're saying for each element in the array of type E, we are going to print it out. And it's going to be great. And we should add a space here because nice quality. And we're actually going to delete this guy here. Let's just take a minute to see, like, we narrowed it down to, what is this, a measly 5 lines of code? 1, 2, 3, 4, 5. Yeah, 5 lines of, really 2, because these 2 or 3 with the signature, like, and crazy. And we still have some errors because, you know, errors always happen. And it's because when we do type E here, we automatically say like that it is an object. And so E here, it's automatically an object because we can't say, like, it has to be. And so inside down here, we can't say int, we have to say integer. And basically what an object means, it means it has a pointer. It's a part of a class, and integer is a class. Not int is just a data type. Integer is a class. And so we can add integer to all of these guys. And it's going to be the same types of values, but we're just giving it a pointer. And so we have integer, 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 blah, 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 blah. And everything's good. And notice I didn't get any errors from my string when I was trying to, you know, print out my string shopping list. And so if we play this, everything is going to work swell, most likely. And here we are, everything ran, and because we did println, it kind of got a little wonky, so we're going to just do print. And then maybe do a println at the end, so then we get like a new line and it's pretty. And so if we run this again, here we are, our special for loop. Our strings printed fine, everything was good. We had these like array here. We had null, 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 that's fine, you know. Everything was good here. And we just created our first generic method. Woohoo! We just, you know, this is generic. This thing can have any type of input that is an array, but inside of the array it could be anything. We don't even know until we call it. It depends on the argument value. Similarly, if we wanted to return, like we say return array, then what it wouldn't be void. What would it be? It would be E, the array. Everything's good. We can even use it in the return type as well as the argument, and you could have ET, you know, and have like a TB that we don't use, or you could return T. Like, you can have as many of these generic things as you want. But the thing is that if you say like E is a string and you want like this B to also be a string, then you would make them the same data type, but say you always want, I don't know, them to be different. I mean, they could be the same, but if you think that you're going to use them differently, then you would give them different values here. And so we're going to actually delete all these. I was just showing you. You can do this with your methods and it's all good, and we're not going to return this array because it's printing, it's a side effect, and there we go. What if you don't want just anything inside of your function? Like here we say any type of, we don't really care what E is, but just make sure that it's a E type in the array. What if we want to say like certain conditions for E, like E has to have, you know, a toString method, or E has to have certain types of methods like a max method or a, I don't know, sequencing method or whatever it is. We can actually do this with our generics. And so that's kind of like interfaces. It's just saying like generic, it's like a more specific way of doing generics. And so you could say like generics, which is like anything can come inside of my function, versus like specific generics. That's not a real term. I'm just making it that term, so it makes sense that everything is generic. But you can be a little bit more specific, saying, okay, I want anything that also has this method. So that way you can use this type of method inside of the array. Like here for our E, the disadvantage of using generics is that I won't be able to use any methods that aren't object methods. Like I can use toString, I can do, if I do E dot, or if I do here element dot, it's only going to give me methods, which, you know, aren't a lot. And so those are kind of the advantage is anything can come in here, but the disadvantage is that, you know, you're limited. And so what's the middle ground? Well, you can say that whatever comes into the array has to have this function. So how do we do this? Well, we are going to create a new project, and we're going to call it generic practice, but of course we got to do this work first. here we are, generics is what we're calling it, and it's loading. And we're here, and we are going to create a special method, and it's going to be called max. And basically, we want our max to be able to find the maximum of any two values. And so to have that, you have to use a compare to function. You obviously, if you have like integers and you have 10 and you have 15, obviously 15 is greater than 10. But what if you have words like, I don't know, peace and calm? Like, which one's greater? Concept, abstract-wise, you can't really compare those things. But if you had the words peace and calm, you could obviously say that calm is, smaller because C becomes before P, and, it's like less dictionary-wise. And so those two things could be compared, as well as characters, like A is obviously smaller than B or something like that. But there are certain things that can't be compared, like if you had something without a compare to method. So like before, last time when we did our person objects, we didn't have a compare to method. So there was no way to say that Spider-Man was equal to Peter Parker unless we did the aliasing thing. And then we could see by testing it, but we didn't have a compare to that like compared like the hair color. Okay, if that's equal, then we could create that obviously, but it didn't have it. And so obviously we wouldn't be able to find the max of two people. Kind of makes sense. Let's write the function. Let's do some code. So inside of here, we're writing the function, and we are going to write public static, open bracket, t extends comparable, open bracket, t, close bracket, close bracket. This is very weird syntax. I hope you think it's weird because it is weird. And so then we have this t is what we're going to return, and then we're going to call this find max, and then we're going to have ta and tb. Let's talk about the syntax here. Basically, t is going to be some type of data that extends comparable, meaning it has a compare to function. That is what comparable means. Comparable means you have a compare to function, so if I have an instance of A and an instance of B, I will be able to look at them and say A is greater than B, B is greater than A, or A and B are equal, and I'll be able to return the maximum. And if there is no maximum, if A and B are equal, I can return either of them, and everything will be cool. But again, if you don't have that compare to method, you wouldn't be able to find the maximum. So you want to make sure like your data obviously has this compare to method. And so how do we, like, let's say, okay, our things are comparable. That's what this guy means. And the syntax is weird, and you have to do this thing because like anything, like when you do comparable, like the compare to method, you have to accept type T. And so yeah, that's another video, but basically you just have to have it there because inside of comparable, there are certain methods that need to say, okay, this T matches up with this T, and everything is good. And we'll talk, when we get to more with generics and classes, you'll understand more about that. And so inside of our method, we are going to do int n equals a dot compare to b. And so this function is going to return either -1 if a is less than b, 0 if a is equal to b, or 1 if a is greater than b. If n is greater than 0, then a is greater than b, so we want to return a. If n is equal to 0, then obviously we want to return either a or b, so we could return b or a. And so inside of this like function, we could actually just do if n is less than 0, then we want to return b because then b is the maximum. If b is not the maximum, then we return a, so we can do return b, else return a. And there we go, we have our function. But how do we know it works? Well, inside of our main, we can do things. We can do system.out.println, and we can find max, because that's what this method is called, and we can put 2, 3, and it will print out the maximum. And then we can switch those and see if it still works. 3, we could keep them the same, and then we could switch them. So this should print out 3, 3, 3. And again, you could change, certain things as well. And what other things are comparable? Well, doubles are comparable, so we could do 2.0 and 3.0. Again, you could change these numbers if you want, but I'm trying to keep it quick here, keep it moving along. We could also print out characters, and so we could do find A, B, which is greater. We could actually do strings as well. We could have, I don't know, hello, and there. So obviously there. And we need to do things correctly here and there. Those would be two things we're comparing. And so for this example, hello there, T would be a string. For this A, B, T would be character. For 2.0, 3.0, T would be double. And for the ones up here, it would be int. And because all of those methods have compare to methods, everything is going to go swell and everything's going to work. So if we run it here, we get 3, 3, 3, and those are the max of all of these. Then we have 3.0, which is greater than 2.0. Then we have B, which is greater than A. And then we have there, which is, greater than hello. So everything's great. But what if we tried to do this with a data type that did not have a compare to method? So here we have generics. It doesn't have a compare to method. So what if we did generics, and we can just call this K equals new generics. What if we did the same idea? We could actually just do Control V because I've saved it. What if we did K, find the max of KK? It's going to freak out because, it's requiring T. We found generics and they aren't comparable. We needed something that was comparable. So if we actually add implements comparable up here, will it work? Well, first we have to implement the abstract methods, but once we do that, everything's good and we can run this. Obviously, we don't want this to happen, which is why an exception is going to, occur. But what if we have the method, but we don't implement comparable? What will happen then? Well, we will still get this error down here because it has to be comparable. And this override thing can go away, but still, it's not implementing comparable. So the data type in FindMaxed could have a compare to method, but you need to make sure it implements the interface comparable or else this isn't going to work because comparable just guarantees that it has a compare to method. You can obviously put one in there and not give it comparable, but it won't allow other objects or other classes to see, okay, you have a compare to function, I can use you to compare things. Interesting, huh? And so we are actually going to get rid of this compare stuff because it's weird, and I'm going to comment out this generic stuff because it shouldn't work. Now, not only can we make generic methods, but we can also make generic classes. We are going to go back to some of our older programs and make, our queues, our lists generic and allow them to hold any data type with generics, which we couldn't do before. So we'll go ahead and go to open project here and go find we're going to open two different projects, our linked list and our QE. We're going to start off with our QE, but then we'll go to our linked list and do some work there. And so we have all these things and we're going to delete up here, or really just close. We're not deleting anything. Never delete unless you're 100% sure. And so up here, how do we make this generic? Well, we're going to add a bunch of T's. And so we'll do T here, any type, or we could do E, or we can do D. We haven't done D yet, so we'll do D. And so we're basically saying anything can be inside of these queues when we do this. And so we also have to make sure anything can be inside of our linked list because that's what represents our queue. And we'll go down here. Notice we have an error here because it's not type N, a string may not be, matching to type D. And so we just have to make this type D, everything matches up and we're good to go. And what's great about this is that when we dequeue, we know it's going to be of type D because anything that we enqueued was of type D. And so we can get rid of this casting. And the reason that this is going to work is because up here we guarantee with these arrow brackets that everything inside of this list, linked list, is going to be of type D. So when we remove things, we know it has to be of type D because that's the only thing our list can hold. And same for peek, we don't have to do the casting because we know that everything is going to be of type D because we declared it up here in our linked list. And everything we enqueue also as well. And so here is all of our things and we can run it and everything is going to work. Also, we have this QE thing, and we should probably do this and do things and uncomment so that we can see what the hell is going on here. And we'll just do this, and we'll see that it works no matter what type of queue it is. If it's a number queue, or if it's a string queue, everything is going to work out because now we have generic queues. They're not just going to be able to hold ints or strings. They're going to be able to hold no matter what. They're going to be decided upon creation what they're going to be, if they're going to hold ints, if they're going to hold, whatever it's going to be. So here, if we run it, we have first out is 5, which is good. We have second out is 7. Here, down here, we have the third out is 6. everything works fine, and this is great. And we didn't have to mess up here like we did last time with the string, like what data type is this? Well, it's type D, which means whatever the first thing that we put in is, whatever we declare it to be, like here in our stack, this is actually built into stack as well. Here we declared it was going to be strings, and so everything that we insert and everything that we pop is going to be a string. And that's what this whole D thing means. And so we did this for our queue, but can we do it for our linked list? Well, we can. And so if we go to our linked list node first, and because if you remember a linked list, it is like a series of nodes. Each node has a data and a next. Here we automatically said our data was an int, but we can actually make it of type D. And we have to make sure that our nodes are of type D. So this is kind of what I was talking about with the comparable. Like it has to have these, arrow brackets around it because it needs to know, okay, the data inside of it is D. And so for all of these nodes here, we also have to make sure that they have these arrow brackets so that we know that this node comprises of only type D. And so inside of our constructors, we also have to change this to D and make everything work out. And then we have the get data. It's going to be of type D, which is going to be, declared what it is upon initialization or declaration. And we have these other things. Our new data is going to be of type D because, it's got to match up. And inside of these nodes, we should make sure that we have these things here because I did a project. It was the most difficult thing ever because I didn't do this thing. I only had node. I didn't do these arrow brackets D. And so do those because it will haunt you if you do not when you're programming. And so making sure that all of these are things you don't need them in your constructors, but you need them literally everywhere else. So we're going to double check here and we're good to go. And so we will save. And notice I also had to do it for my return types as well as my parameters. And we'll go to linked list. And now we have some errors because we've done things. And so our count will still be an int. We'll add D here. What is D? Well, we have to add it up here and do that. And we'll scroll down. Our constructor node was also going to be of type D inside of it. Like the data is going to be a D. We're going to add only type D to our list. And we're going to make sure this node is full of the D data type. And everything else is going to work out well. Here, we're also, when we get things, we can only get things of type D. Here, our index, that's going to be an index. It's going to be fine. We're actually going to have to get rid of this whole catch-all. We can add an exception maybe if we learned about that before. You could add an exception maybe if the index wasn't, the correct one, or add some kind of try-catch to handle that. And yeah, because we're not going to be able to return integers because we don't know what D is going to be. It could be characters, it could be strings. And so if they don't match up, like if -1 doesn't match up like with string or int, and it would match up with int, but say we create a linked list of strings, like that's not going to match up and we're going to get errors and we're going to get compiler errors in here, which is why we're going to have problems. And here is a huge problem that is important to recognize. Here it says incompatible types. Object cannot be converted to D where D is a type variable. D extends object declared in class linked list. What does that mean? This is what I asked myself when I was doing projects. Well, it means we need to add a D here. Why couldn't they just say that? Why couldn't they give you a little, because, yeah, errors. And so what it means is that I wasn't saying what data it could be. Yeah, we know from everything else it's going to be type D, but we have to actually say when we create a new node, it's going to have the same type D inside of it. And we're going to scroll down. This is super important. Make sure you do your Ds in front of your nodes. It's very important. Or else you'll get errors and you'll not be a happy camper here in the coding world. Again, here's our node. We got to add type D. And make sure your syntax is right or else your entire program will freak out like mine usually does. And we're good. And notice we had to do it when we created this linked list. This is like how we're inserting what type of data we're going to use. We use string here, and string is like in place of D, kind of like our arguments versus parameters. Here, our argument would be string and our parameter would have been D. Kind of making sense? So now our linked list, if we run this, everything should work out fine. And we don't actually use our linked list because there are things wrong with our linked list. Like last time we didn't implement everything that could possibly be implemented, but that's, that's okay. But we do know that this data structure is now generic because we actually implement this D. And again, you can have multiple things here. You could have T, you could have E, as many as you want. And you could even say that T like extends comparable. And you might be wondering why sometimes we do implements and sometimes we do comparable. Well, implements is when you're saying a class implements something. Extends means like you're extending, you're saying, and this should have a T here. Extends means you're saying like, okay, T has to have, we're going to assume that T has this compare to method. We're not saying that T is going to implement it right now. We're saying that we're assuming that T already has this comparable method and that it's going to be fine. Okay, so we don't need this extra thing. I was just showing you. You can do it there. So that's it for this video. Today we learned about generics. We learned how to make generic methods, how to make those generic methods like either accept, whatever type of data type we want, or, return whatever type of data we want. And we made those generics more specific by saying like extends comparable, meaning we had to assume that there's going to be a compare to method with our max function or find max function. And we made it a little bit more specific, but again, allowed it to be any data type that had this functionality, which was great. And then we actually applied it to our classes where we made our classes generic, meaning that our linked lists, our queues, our stacks, they could have any type of data inside them and could be accessed, all good, all is fine. And so that's it for this video. The HackerRank challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.